Good afternoon, everyone. I hope you had a pleasant meal. Very tasty one. I like the croque-monsieur. And today we are going to start the afternoon of this Thursday DevFest by having a look at a very popular subject nowadays, which is artificial intelligence. Now, I'm sure everyone knows artificial intelligence, and I'm sure everyone also knows or even uses AWS. Now, imagine having both being tied together, and that might be my last presentation I might give, because they are going to present you something that can help you offload your work, and I'm quoting them. So, presented by Victoria Seaman, coming from California, and Tiffany Souter, coming from Paris. Please welcome for Deep Dive, Building AI Agents Using Amazon Bedrock.
The conference so far. Good? Well, this is my first time at DevFest, and I am so impressed. It's definitely one of the most creative conferences that I've been. So definitely worth the trip from California to Paris and then the train to Nantes. So what we will be talking about today is about AI agents on AWS. The MC said, oh, everyone is utilizing AWS. I don't have expectations that you all are using AWS. Actually, how many of you tried AWS? Raise your hand. Oh, wow, that's a lot more than I expected. Well, hopefully after this presentation, more of you would be interested to try it. So today I'm joined by my colleague, Tiffany.
And, oh, OK. That's me jumping in. So hi, everyone. Thank you so much for coming to our talk. So I've been working at AWS for 2 years as a developer advocate. And I've been a few times at DevFest now. It's always so nice to be here. So you're always an amazing crowd to be. So thank you so much. And yeah, Victoria.
Yeah, so we both are specializing in AI. So today we are going to share our AI secrets after a few years of experimenting. So let me ask you, how many of you sometimes just find yourself doing the tasks that just feel kind of repetitive, and you think, I just wish I could automate this, right? Because I don't feel that I am applying my best potential and really showcasing what I can do, because I'm just bogged with these time-consuming, tedious tasks. This happens to me quite often. So what we will talk today is how to take some of these responsibilities and then break them into well-defined tasks, and then how we can then create an agent that can execute those tasks on our behalf. So whether you're a DevOps engineer or software developer or solutions architect, we can apply the same concept. So today, we are going to be on the mission to help our customer. And our customer called Swissbox. They're a growing tech company. It's a fictional company that we created. And they provide file sharing services. So they came to us as technical experts, and they said, you know what? We've provided our file sharing services to private customers, but now we want to take it to public. Please help us to build analytics systems so we can figure out how much we should charge our clients. OK, so we have now a request. What do we do as technical experts? Well, the first thing is that we kind of have to start diving into how Swissbox is structured, right? What technical stacks they use, what services behind, where data is stored, what's the safety and regulation requirements in terms of accessing this data. Once we get this information, then we can go and look at some of the reference technical diagrams, maybe find some customer stories, right? More analyze from a technical perspective now how we can integrate this analytics system. Once we get this information, maybe we need some help. We can talk to a friend from some specialty team, right? And then as developers, we often want to put our hands on, right, and build some prototype and validate our assumptions. So then typically, like when I worked as solutions architect, after I do all of this research, I go back to my customer and I present them a proposal in the form of PowerPoint or something like that. And what happens? The customer, after a few days, came up with different requirements, right? And now they can say, oh, this was wonderful, Victoria, but now we want maybe to add data warehouse solution. And then what happens? We have to go and do this work again, right? So what we want today to talk is how to now we can break this and make it as agentic workflow so that we don't have to spend our days and days on answering this, small change in requirements. So we will be utilizing a Bedrock AI agent, so AI agents on Amazon Bedrock. So now let's imagine we had the same question. How to build the AI analytics and how much it's going to cost. Well, the first thing that we can do, we can build a tool where we store all of the information about Swissbox, so we can retrieve it right away about its configuration instead of us trying to analyze. Second, once we get all of this information, we can also utilize now the GenAI models that have the capability for software development that will help us to convert those requirements into a technical stack. And then we can create infrastructure as code that will help us, instead of writing it all from scratch, that we can get a good start and have some kind of MVP that we can deploy. And also, customers, they always wonder how much it's going to cost. They want to present a few, need to know different maybe options, right? And finding out the cost can be quite consuming, right? To figure out how much different proposals we cost. So we can also build some kind of a tool that will estimate this. So once we build all of these tools, we can provide this to our agent, and then agent will take all of the results from different tools, use an underlying AI model, and then take all of the information, there might be some chunks of documents, some detailed cost estimate, and provide an answer to our customer. And all of this cycle actually happens in a matter of seconds. And Tiffany later will show a live demo where you can see where we can just change requirements, and right away we will be getting this information in a matter of seconds. So let me show you now a sneak peek of what we will be building. So the first thing, we will build solutions architect assistants, where we're saying, hey, tell me more about Swissbox, where the data is stored. And you can see it tells me, oh, the data stored is in Amazon S3. Now I'm saying, well, how can I create an analytics for my application? And it gives me the steps, and it gives me some of the services. Then I'll say, okay, this is great. Well, now can you change this proposal and create for me a Terraform code? And it gives me the Terraform code that I can then use to provision architecture. So kind of like a DevOps assistant. And now I'm saying, okay, this is great, but before I go and deploy all of this, kind of now want to understand how much it's going to cost, right? So now I have a financial analyst assistant that can tell me, okay, based on your Terraform code, this is how much it's going to cost for you monthly. So I hope you're excited to go with me on this journey and build this intelligent AI agent. We will go through all the steps. So we just discussed our use case. So the core service that we will be utilizing is Amazon Bedrock. Quick question, how many of you tried Amazon Bedrock? Okay, like very few hands. So super crash course. Amazon Bedrock, basically a service that allows you to access hundreds of different models with one API call. So you can access Amazon, Anthropic, Cohere, Meta, Mistral, and Stability AI models, just utilizing one API call. It's a fully managed service. It's a serverless service. And as I said, many different models. We constantly add new models. So recently we added Meta Llama 3.2 for image generation, Stability Diffusion 3. So there are different models available for you to try. But the problem is that we have this task of Swissbox came to us, and they said, we need data for a specific solution based on our configuration. And the out-of-the-box models, they don't know about Swissbox, right? So how can we customize the models so that they will learn about Swissbox?
So I have an answer for you. So okay, now we're going to see how you can customize your LLM. There are different ways that you can customize your LLM to be specialized in certain tasks. I'm going to present you the different solutions in an increasing complexity way. So the first way you can customize an LLM, the easiest one, is prompt engineering. You might have heard of this. Basically, what you'll do as a developer, if you want your LLM to behave a certain way or have guidelines or know to answer a certain way, then you write what we call a pre-prompt. And basically, whenever your user is sending a question to your LLM, you will put that before the question or along with. And so the pre-prompt basically contains all of the guidelines and all of the requirements that gives context to your LLM. For example, if you're building a solution architect assistant, you will give a pre-prompt such as, you're a solution architect expert in AWS services, you should answer precisely to questions, you must be polite and respectful and not be offensive and stuff like that, and then you send the query along with it. What it does is that the LLM understands that it is in a certain context and it needs to answer in a certain way. The second way you can customize an LLM is a RAG. So that stands for Retrieval Augmented Generation. And what it is that basically you have your LLM and you give your LLM documentation. So it's the step further than prompt engineering, because here you basically give your LLM the database, like the source of truth. And for example, in our case, we have this company, Swissbox, and when the LLM was trained, the data was not available on the internet. It was not public. So our LLM doesn't know anything about our company, Swissbox. So whenever you ask a question to an LLM about specification about Swissbox, the LLM might be either it doesn't know or it's going to make up some answer, but you don't want it to make up, to guess, you want it to know. So what you'll do is that you'll give all of the documentation that you know about your company, so your private data. You will store it in a database, and you'll give it access to your LLM. So whenever you ask a question about Swissbox, the LLM will be like, I need to look through the documentation to know exactly the answer to that question. And it will generate an answer that is documented, and it will give you the source back to all of the facts that it's giving you. So it's preventing from hallucinations. Another way you can customize an LLM is fine-tuning. So here it's a little bit more complex because you need to recalculate the weights of your model. So you need to go back to a phase of training. And for fine-tuning, you're basically specializing your LLM to answer in a certain way. For example, if you have a call for bids, like appel d'offres, and you want to have an LLM that is your assistant in answering appel d'offres, much faster, then you will show it hundreds, even more, examples of call for bids and different ways you answered that call for bids, and it will know exactly how to answer an appel d'offres, and it will be specialized in that specific task. And finally, you have continued pre-training, where you don't want your LLM to be specifically specialized in a task, but you want it to be knowledgeable about a domain. For example, you're a researcher in cancer research, and you want your LLM not just to be like ChatGPT and answering questions. You want it to have knowledge about research in cancer. So what you do is that you're continuously giving it new data about the latest research and papers that's gone out on cancer research. And so your LLM is specifically very knowledgeable about that domain. So fine-tuning, you will need to have what we call labeled data set with examples of inputs and outputs. It's not the case with constraint pre-training. Here in our case, we will focus on prompt engineering and RAG because we have the SwissBox app and we want our LLM to be knowledgeable about our company. Fictional company, but company nonetheless. So here is how a RAG works in details. So you have your data source. If you have a company you have somewhere, like the ground truth of your company, you might have a GitHub repo, you might have a Confluence file, like documents, files of architectures, PDFs, and everything. So you point to all of those data sources. And then what's happening is that you build chunks of data, and then you use an embedding model to vectorize all of this data. So you basically transform words into vectors, and then you store it into a vector store. And then if you have a user that is specific, like asking a specific question about your company, like what is the SwissBox app, for example, then the question will be transformed into a vector with an embedding model. And what's going to happen is that you're going to have a vectorized search through the vector store, and all of the data that is related to your question will come out as a pre-prompt. So that's why we call it an augmented prompt, so retrieval augmented generation, will be added to the context of your question, so your LLM will know exactly how to answer, because it will have chunks of data that it has retrieved in your documentation. And this is how also it's really cool, because it points out to the source of truth in your database saying, I know this answer because I found it here in your documentation. So that's how we're going to build a RAG. And yeah, so Victoria is going to show you how to implement this.
Yeah, so now that you got a crash course in terms of theory, how it works, let's now work on the steps. So one thing I wanted to elaborate more on how AI agents in general work, because a lot of the things will be abstracted when we work in the console, when we start doing the coding. So basically what happens under the hood. When we give a task to our AI agent, so what it's going to do, it's going to take the initial prompt, then it's going to take our task. For example, our task is, I want to build analytics, tell me how to structure it and what it's going to cost. And then it's going to utilize a model to break it down into more steps based on the tools that agent has at its own disposal. So we're going to build 3 different tools. And the tools can be, let's say, 2 main categories. One is information retrieval, so like a Node database. And the second, more like execution, when we call particular API or when we create a Lambda function, right, we trigger it. So those are 2 different types. And the agent will look at the different tools, and based on this, will come up with a plan. Or it might say, well, this was a great question, but sorry, I don't have an answer based on the tools you provided to me. So once it figures out the plans, and it will start executing and getting results back to agent. And basically what agent does, it evaluates after every single step, right? So it gets, again, from the results from prompt, and then it iterates and it understands, well, do I need to change a plan, or do I just go through the next step? And Tiffany later will show this in the console. It's called like a trace. We can see how agent determines which steps to take next. So you will see this logic. And once it finally finishes all the steps and then figure out, OK, now I have a final answer, it's going to provide it back to the GenAI model, and it's going to take all of these different results from different tasks and then summarize it for us in a concise way to get to the final answer. So now let's dive into how to build different tools. So the first tool that we're going to build is Solutions Architect Assistant. And for this, we're going to utilize knowledge bases. So we're going to create a knowledge base that will have information about our SwissBox application. So Tiffany earlier described about how how RAG works. What we are going to use today is a knowledge base in Bedrock, which is basically end-to-end service that allows us to create RAG in a very quick way. So there are 3 steps. First, you select a data source. So it can be, let's say, Amazon S3 bucket, where you have different documentation, PDF, text, docs, CSV files, and so forth. Or it can be web crawler, so you can crawl different websites, or some other additional data sources that's being added, such as Salesforce and SharePoint. Then you select which embedding model to use, whether you have like English optimized embedding model or multilingual. And then the third step, you're basically selecting a vector database where the final, right, so it's going to take all of the data, we'll then use embedding model and store it in a vector database that is optimized for fast retrieval. If you are just, let's say, trying to get started, trying to build demo, you can try Pinecone. They have a free tier. We're going to use OpenSearch serverless. When you go through the steps, it just creates a new database for you, so it's also kind of like an easy way. Or you can use more like enterprise ready and connect to your existing databases, such as Aurora, MongoDB, and Redis. OK, so now let's see how to actually do this in the console. So the first thing that I want to do is I want to check that out of the box, the Claude 3.5 Sonnet, one of the most intelligent model, doesn't know anything about Swissbox, right? So it doesn't hallucinate, doesn't provide us something. So here I'm just selecting in Bedrock Playground a model, and I'm providing a prompt, and I'm saying, explain me the components of Swissbox. And you can see Claude is telling me, I apologize, but I don't have information about this, right? So it's not aware about our company. Well, there are a few ways that we can, if we just working with a model, we can, of course, provide some kind of a document, right? For example, reference diagram, or just a PDF file, and ask the question, and it's going to provide us the information. The challenge with this approach, when we just provide some document, that first of all, we cannot share it across the team. Then we are limited with the context, right? With Claude, for example, it's 200,000 tokens, which is maybe like 100, 200 pages document. So you cannot really ask a lot of questions, right? So if you want to have more of a bigger scope with the different documents, that's when you will need to create a knowledge base. So how do we create a knowledge base? In Bedrock, there is no option to create, okay, whoops, 1 second. Yeah, so for this demo, we actually created a GitHub repo. We created a few PDF files to make sure that our company is well documented. So now we are going to utilize different data sources and create a knowledge base. So we select knowledge base, we click create a knowledge base, and then we can create different data sources. So the first data source will be a web crawler. So you can pick the web crawler and then specify the scope of crawling. You can set the parameters in terms of like what link, and then how deep the depth of crawling, if it's just domains, subdomains, as well as if there are any exclude or include patterns. For example, let's say I don't want to crawl any pull history, so I can exclude it from my crawling, so because the information is not very relevant. Then you pick the embedding model and then select the vector database. So as I mentioned earlier in the slide. So just to get it quickly, get started, I'm going to select OpenSearch serverless. And it's going to provision a new database for me, so I don't have to do any kind of API configuration or provision on my own. So you can see here the first data source was created, and just for the sake of time, I kind of like cut the demo and I added a new S3 because it's the same steps. You just put the bucket name, and then you go through the same 3 steps, and it will create a new data source with S3. So once you add all your data sources to knowledge base, you can actually chat immediately and check that your knowledge base can retrieve information. So here, what we do, we adjust our prompt. So Tiffany mentioned about prompt engineering, how it's important. So if we want, it's good to assign a role to our agent. So our agent has a particular tone of voice. So here I'm saying, well, you are experienced AWS solutions architect, so provide me an answer in this kind of tone of voice. So now I'm asking the same question, explain me about the Swissbox, and as you can see, it provides me the answer that Swissbox is a serverless application for file sharing. And as you can see, it also provides the link to where the information found, and it has these chunks. So it identifies several different chunks, but then it took all of those chunks, right, and with the Bedrock model, provide me a concise summary on the left. So that's how we can quickly create RAG with Bedrock utilizing a knowledge bases. So that's good. That's our tool number one, which is kind of what we used to, right, in terms of chatting. But let's say now, how can we work with infrastructure as code? So nowadays, the different models, they become more and more versed in software development. How many of you are now utilizing like code companions? Your hand? Yeah, quite a lot. That's great. So one of the things that what also is interesting about this model is that you can, what Tiffany mentioned earlier about fine-tuning, you can actually fine-tune these models based on your custom repository. And in this way, it's not only providing you the answer based on the general knowledge, right? But it's going to take the standards that you're using in your company and apply them when you create your infrastructure as code. So in our example, we're going to utilize Terraform. Terraform quite frequently used for a multi-cloud deployment. So the next task, basically, OK, we got all of the information in terms of requirements. Let's now, based on those requirements, outline the Terraform code. So now I'm going to switch to my IDE. And the first thing that I just wanted to show you, we did the knowledge bases before in the console, but if you want to do it in IDE, it's just a one API. It's called retrieve and generate, where you provide your knowledge base ID, and then at the top there is some model that's being used, Claude 3.5 Sonnet, and actually it's Claude 3, yeah, for that tool, and that's it. So it's like one API call to implement knowledge base in your code. So the first thing that what I want to test, just to make sure that it's working, I'm going to ask the same question, like, can you tell me how to build analytics for my Swissbox application? And once I execute the query, it's going to outline for me all the steps. Great. So now I can take this as my requirement and pass it to my second tool and say, OK, well, now you are a DevOps engineer, right? So I have my second prompt. I'm building my second tool. And please utilize the requirements from customer and now outline for me a Terraform code. So here, what I want to do, I want to keep the information, right? So I'm going to save the Terraform file into S3 bucket. And from there, you can implement some kind of testing, right, and other things to validate later that this Terraform file is valid. So I got my query in terms of what I want to build. So now I'm just going to run the tool. And it will take like a few seconds, and then the new Terraform file will appear. So here, I'm just going to download the file to validate that it's accurate. As I said, in the production, you will most likely have some kind of other steps, right, to build. But as you can see, the file is actually quite long, yeah, because these models become quite efficient in coding. It was like over 250 lines. So it saved quite a lot of time, right? Like we didn't have to write all of this from scratch. Of course, there will be things that you will need to adjust, you will need to configure, but it's a really good starting point for your MVP. So I tried to deploy the model, and I'm getting, it was deployed, and then I could see these results in the console. So one of the things that you might be, wow, she just went ahead and deployed 250 lines of code. How much it's going to cost, right? So how many of you here try to use pricing calculator? AWS Prime. OK, a few people. How was your experience? I see smiles. Yeah, to be honest with you, like when I tried to use pricing calculator, I often felt like I need to have a PhD degree in finance in order for me to really understand how it works, because there are so many different options and so many different features that you have to assume. So I don't have a PhD in finance and the patience to do this, but we're going to ask AI to help us with it.
Yeah, nobody has a PhD in like FinOps. Like, do we have FinOps in the room? No. Yeah. So probably none of you like to actually estimate the cost of your infrastructure, and also, when it comes to estimating the cost of your infrastructure, you want to be precise because you want to know exactly how much you're going to pay by the end of the month. So we don't want to ask an LLM to answer that question to us because it's like not going to be reliable. The LLM might try to guess something, but we want the numbers to be precise. So instead of just using the LLM, we're going to use a tool called InfraCost. And this is an open source project that can estimate the cost of your file from a Terraform file. And that's actually much more reliable than just asking an LLM to guess out on the go. So that's exactly what we're going to use. We're going to drop our Terraform file inside an S3 bucket. And we're going to have a Lambda function running the InfraCost library to estimate the cost of the infrastructure. So here's a short presentation of how it looks like when you run it locally. You have the cost broken down by services, monthly, and also by usage. So that's the kind of tool you want to use if you want to estimate the cost properly of your infrastructure from a Terraform file. So yeah, here you have like how much the Amazon Redshift is going to cost you in a month, and yeah. So that's great. We have this tool, but how do we allow our LLM to use that function that uses InfraCost? This is where we're going to use orchestration and agents. This is where everything that we showed you before is going to come together. Because remember, what Victoria presented at the beginning is that we want just to be able to interact with a chatbot. We don't want to do any, like we don't want to run the functions ourselves, like we don't want to push buttons. We want the LLM to be able to push button itself. So with agents, we're going to give hints to our LLM. The LLM will be able to perform those actions for us. And we do this with action groups. So basically, what you're going to do, and like be very attentive because this is where everything falls apart, like not falls apart, but comes together. We have what we call an API schema. And you give this to your agent. And basically, in this API schema, you give all of the functions, like all of the tools that we've built before, and we have a description right beneath it. Like there's a field called description, and you need to put in native English exactly what this function is going to do. Like for the answer query, you want to say, the LLM is going to answer a question specifically about like Swissbox with a RAG. And for the YAGGen tool, you're going to say it's going to generate a Terraform file for creating an infrastructure. And for estimating cost, it's going to estimate the cost from a Terraform file with an InfraCost like library or something. And so whenever you're going to ask a question to your LLM, then the LLM, because it has a chain of thought, it has reasoning, it will be able to, if you ask a question to your LLM about Swissbox, it's going to be thinking through your question and saying, I need to answer a question about Swissbox. What do I have in my toolbox that will help me perform this action? Well, tool number one is, so I will retrieve data from a vector database and answer the question. If you're asking something like, build a Terraform file for me for this architecture, then it's going to think to itself, I will need the second tool because the description says that I can build a Terraform file from this. And so it will like run the function, like the Lambda function, drop the Terraform file instead of an S3 bucket. And if you ask for an estimation of a cost of a Terraform file, then it will know that it will need to use the third tool that we gave it, take the Terraform file, run it through the infra cost, and then make a summary of the monthly cost. So this is time for live demo. I'm going to show you everything, and this was not working before, so I'm just gonna draw, yeah, right here. Okay, so here's part of the code. And here's the API schema. Yeah, maybe you want us to be a little bit more bigger. Okay. Make it even more comfortable for you guys. Okay. So this is what I said about, like, you have the path for the answer query, and right here you have something called, I don't know what this is, but yeah. So the description is like the answer query functions allows to answer specific questions about the Swissbox app by querying a knowledge base pointing to sources like GitHub repo. Like, I've been very descriptive. I've done this with all of the different functions that we have. And then you have an index folder where you put your Lambda function. And in the Lambda function, you'll have how you process the API. Like, you have the different paths, and from the different paths, it will know which function it will have to run. And so going back to our console, I will show you directly in Amazon Bedrock how it falls. Can I make this bigger? Okay, it's a little bit better. So here we have our agent that is deployed in Bedrock. And okay, we have our action groups here. And the file that I showed you, like the API schema, is dropped in an S3 bucket. So we are pointing to the schema on the S3 bucket. And we have an ECR, so a container that is running with all of our function and Lambda functions. So now we're going to test the agent and see what it. So I copied and pasted a query. If we have time after, we can try another query. But basically what I queried to my agent is I would like to add powerful analytics with data warehouse to the Swissbox app. The solution must fit for near real-time insights of application logs. It needs to be plugged to a dashboard for data visualization, make it the most cost-effective possible, generate the Terraform file for it, and estimate the cost. That's a pretty big query. So let's see if it works. Live demo. So what's interesting is that, is that you can see the trace. What the trace shows you is the chain of thought, so the reasoning of your LLM. And so, like, it shows us what has been sent as a pre-prompt, and here you have the reasoning of the LLM. So it's not even outputting this for you, it's thinking through itself, and we can read like what it has thought. It has thought to add powerful analytics with a data warehouse to the Swissbox app that can provide near real-time insights, I need to, 1, understand the requirements of your architecture better. 2, search the knowledge base for relevant information. So it's going to go to the knowledge base. 3, based on the findings, propose an architecture that meets the requirements. 4, generate the Terraform for provisioning the proposed solution. And 5, estimate the cost of it. And so once it does this, it will show you all of the sources that it has found useful to answer the question. And then trace 2, it went through 5 different steps. And then, I'll go through. This is interesting. Okay, So now it says the knowledge base provided some good options for near real-time analytics, and now it's breaking it down for you, like CloudWatch log insights for interactive log, OpenSearch services with Kibana for log analytics is giving you all of the details. And then it says at the end, let me generate the Terraform code for the solution. And now, look at it. It knows that now it has to use the YakGen function. And so it's now generating the Terraform file to provision the services. And it says that it's dropping the Terraform file here in an S3 bucket. And then trace4, it has done all of this, like while I was speaking. The Terraform code for provisioning the open source was dumped, was generated. Now let me estimate the cost. And now it knows that it needs to use the Yak estimate tool because I gave it the path. And it's looking for the Terraform file that has been dropped in the S3 bucket. And now it's using the infra cost to generate the estimation of the cost. And it says, here's the breakdown for monthly cost. And it's giving you all of the details. So now it's reading through that text, and it's giving you the breakdown right here. The monthly cost will be, the OpenSearch domain will be $27, the instance, $26, and you have all of the details. And you can keep on discussing with your chatbot right here, make it, make
Let's
it
ask
more.
audience what questions they want to ask.
Oh, well, yeah.
Anyone wants to suggest us a prompt to ask an agent?
Like right after this.
Yeah.
If you guys don't have an idea, I just ask something randomly, make it more scalable or something like that.
Yeah.
Okay.
Any prompts? No?
If ever you have an idea,
Yeah.
I'm just going to show how it goes through thinking. I just asked, make it more scalable, so bigger. And so to make the proposed solution more scalable for handling increased log volumes, I will use larger open source service, enable open source service cluster auto-scaling, and automatically add and remove data for the node base. And so it's going to re-update the Terraform file and remake an estimation of the cost for us. So that's orchestration can be very powerful, because then it's not only just your LLM that you're chatting with and it's trying to guess the best answers. Here you're giving specific functions to make sure that your LLM is right on point and useful for every single questions that you can have for it. So let's see if it has generated. Yeah, it has generated the new solution. And it's now much more expensive. It's $423. It costs monthly with the breakdown of now the AWS open source domain costs $379, and it's telling you why it has made those choices depending on your requirements. So, yeah. Shall we go? Do you guys want to try a query, or are you going to go on? Yeah, okay, let's go.
We're good.
Yes.
To summarize, thank you, Tiffany, for showing us the live demo. So as you've seen, we got different answers, right? And one of the reasons is because the Gen AI models are non-deterministic, right? So you ask the same question, and it can provide different answers. So if you want to get more of a consistent answer, you really have to provide more information with prompt engineering, right? So if we were working with this, we probably would have outlined, right, which services we want to use, or be more prescriptive so that it wouldn't generate for us a different design every time. So now let me just wrap up. To summarize, we went through so many different things today. So 3 main key takeaways. As we were discussing those tools, we built 3 tools, right? But we can build as many different tools as we want. And I hope that as we were going through the presentation, kind of sparked ideas in your head in terms of what you can build, what kind of task you can automate. So as you start on this journey, the first thing that what we encourage is to evaluate different models, right? Because, for example, we used Claude 3.5 Sonnet. If we used Claude 5 called Opus, it could have cost us up to 5 times more, right? So evaluate, see if a smaller, faster model will provide you the same kind of answers, and you don't need to go to a more intelligent model that has more parameters. Second, think about different ways to customize models. So Tiffany described with a prompt engineer and RAG, right? So we used RAG for a knowledge basis. We could have used fine-tuning to fine-tune for our second tool for software development. So think about how can you customize a model so it's not just this general knowledge, but really make use of your data. And lastly, with agents, it's really important to provide good descriptions for your tools so that the model knows which tools to invoke as it builds this plan, right? Because if you provide a very basic descriptions, it might not understand, oh, so that for this particular task, I need to invoke this tool. So try to be as prescriptive as possible when you build your API schema. And with this, we just want to give you a few resources to get started. So the code that we shared today is in the first GitHub repo. So if you want to go and build it yourself, you can go with a step-by-step, and you will find all of the instructions there. Second, GitHub is a general GitHub repo on Bedrock. So if you want to try to do like a fine-tuning or build guardrails, that's where you will find more of different examples on Bedrock in general, not specifically for AI agents. And finally, as we were discussing about the API schema, we like to automate things so that we don't have to write all of this descriptive details about tools. So we built this PartyRock app where you can just an outline about your tools, and it's going to generate an API schema for you, so to give you a good start. So with this, we just want to say thank you so much for joining. We hope you enjoyed this session. Please let us know in the survey so we could get your feedback and hopefully improve next time. And feel free to connect with us on LinkedIn if you have any other questions. So thank you, and enjoy the rest of the day. Thank you.